There are two problematic facts for our current astronomical view of what the universe looks like, of what the composition and structure is of the universe. The first fact is that the Earth is supposedly 93 million miles away from a spherical fire that radiates light in all directions. And that this spherical fire has been burning for 4.5 approximately billion years. In other words, the age of the sun is 4.5 billion years, and it has been shining that entire amount of time. And since we know that light moves through space, moves through empty space until it strikes something, the light from the sun billions of years ago must still be moving. And so the second fact is that we know that space-time is curved. We know that there is a curvature from the fabric of space that affects light. And the amount of time or the amount of distance that light would have to travel in a curved space or over the surface of a ununiformly curved space before that light travels back in the same direction it was originally emitted is not treated in the modern astronomical mindset. And so, in other words, where is the light that was emitted from the sun 4 billion years ago? Where is that light right now? And how much of a curvature has it experienced? I think part of the reason that we normally don't consider the persistence of light is because we can only observe light when it's coming right towards us. We don't see light from the side. If a light ray goes past us, we don't see it. It's only when it comes directly towards us that we can actually perceive its presence. And so the fact that the sun has been emitting light since its inception, that there is a continuous stream of light that travels out from the sun, that moves out into space, and that this has been happening for billions of years, doesn't really factor into our modern mindset. The assumption has been that that light just travels in a straight line, and we know that's not true. We know that's not the case. And so we need to start thinking about where that light is and where it has gone. And so when you start doing the math on it, you notice that there are only 360 degrees in a circle. And for a ray of light to turn around and come back from where it came from is only 180 degrees. And so when you divide that 180 degrees by 4.5 billion light years, I mean, if the light only deviated 1 degree in a year's worth of travel at 186,000 miles per second, if that light only deviated 1 degree, it would have turned 4.5 billion degrees. And since all of our calculations on the distance of the stars and the movement of the stars and the structure and composition of the stars and the age of the stars all rests on this one notion about light, on the assumption, it all rests on the assumption that this light travels straight from one point to another point that is, in a lot of cases, well, billions of miles away from that point. Now, it's it's common in the astronomical mindset that these things have physically moved since the light has traveled, supposedly. These supposed objects have traveled, in other words, they're moving, they're in motion, since the light arrived. But the fact that the light bends, the fact that that very light that our own sun is emitting might actually arrive back at the Earth to appear at a distance is never factored into our modern mindset on what the universe really looks like, on what the universe really is. And so, as an alternate word, as an alternate form for construction of what actually might be when this information is factored in, I'm offering the word astrotome. And this is where the word astrotometry comes from. And the word astrotome actually comes before astrotometry. It came, I think, 2 or 3 years before I came up with astrotometry. I came up with the word astrotome to use to differentiate what our common notion of what the universe is from what it actually might be when this new information, when this new concept is factored in. And so I'm really interested in hearing what other people have to say about this. I'm really interested in interacting and talking about this. I don't have all the answers. I have questions. I have proposals. I have possibilities. And there's several different things that spin out of this. There's several different possibilities that I'm considering that I would believe more accurately represent, or more likely represent, the actual structure of the universe and space-time. And I'm very excited about the opportunity to present those. And I'd love to hear the comments. Thanks. Bye. Discussion, please.